Okay, so I want to cover dimensional analysis with you guys, and I want to look at these types of problems. We'll go kind of easy to start. We'll get a little more challenging with time problems. And we'll add a second feature with rate problems. We'll add time into something like a length problem. And then we'll deal with volume problems. Okay? So dimensional analysis is a method of unit convergence. And we're going to use kind of like sort of a strict SI method for doing this. There are other methods. In chemistry class, they might do this slightly differently. But if you learn this way, it can be applied really anywhere. Okay? So basically, dimensional analysis is just a way to convert one type of unit to another type of unit. Okay? One type to another type. And we've touched on a few of these already. Within the metric system, it's fairly easy. So for example, you might be asked to find the number of millimeters in 25 kilometers. Okay. So if you know a few things about this, you know that 1,000 meters is equal to 1 kilometer, right? And you know that 1 meter is equal to 1,000 millimeters. You can essentially make what are called conversion factors. Okay, so this would be one conversion factor, and this would be the other conversion factor. Now you might be able to do this directly, depending on your skill with the metric system, but if not, then you go through your conversion factors. And so the way I would do this method is I would, for step one, write your starting point. Okay, so your starting point is 25 kilometers. And then you're gonna multiply by the first conversion factor, by the appropriate conversion factor. So you got to look for the conversion factor that includes kilometers in it. Okay, so your first step in this case then would be 25 kilometers times 1,000 meters per kilometer. Okay, so we're taking that 1,000 meters equals 1 kilometer, and we're writing it like this: 1,000 kilometers. Okay, 1,000 meters per kilometer. That's what we're saying with this. Okay. Now I want to note something here, okay, because we can actually write this conversion factor slightly differently. We could say that 1/1000th of a kilometer is 1 meter. So there's 1/1000th of a kilometer in a meter. So these are like equivalent, but they're used in different scenarios, okay? And we can look at one where you have to use it in this method. But from 1,000 meters is equal to 1 kilometer, you can either say there's 1,000 meters per kilometer, or there's 1/1000th of a kilometer for every meter. Okay, so we're writing this, but in just slightly different forms. And just something to note, hey, like when we're writing our conversion factors, this is the inverse of this, right? So we're inverting the 1,000 by putting 1 over 1,000. We're doing an inversion of it, okay? And then we're just inverting our units, right? So instead of being meters per kilometer, it's kilometers for every meter, kilometers per meter. Okay, so then we come down here and we just do the math, right? And what you'll notice here, and the nice thing about this method, is you're always bringing your units along, okay? And if your units are going to work out, then you know you're on the right track. So 25 times 1,000 gives you 25,000, okay? And then if you look at your units, you've got kilometers, meters, and then kilometers to the -1, okay? So kilometers times kilometers to the -1 is just like canceling out. So there's no kilometers left anymore, okay? This is kind of our goal. We want to cancel out what we don't want, and we want to be left with what we do want. So our first step is to go to meters, okay? 3 multiplied by the second conversion factor. Let's see, factor 2. Okay, so the second conversion factor is going to take your meters, 25,000 meters, or if you want, 2.5 times 10 to the 4 meters, okay, times the next conversion factor, which is that there's 1,000, or 1 times 10 to the 3. millimeters, right, for every meter. Millimeters in every meter. Okay? I think you can see that what you'll get here is 2.5 times 10 to the 4 plus 3 is 7. Meters will cancel off, and there's your answer in millimeters. So just a little aside here. This value is written in scientific notation. Essentially, it's just a way that we can write a value in terms of powers of 10 in order that we don't have to write this number out. Okay, so what we did here, if you remember, is we took 25,000, we multiplied it by 1,000. So the value you get at the end of that is 25,000,000. Okay. So I just want to look at this number and explain how it translates to this. And I mean, the simple way, without really thinking about what you're talking about, is just 3, 6, 7, 2.5. There's 7 things after the 2. One way to think about it. That's kind of the simplistic way to think about it. I think a better way to think about it is like what we're saying here is it's the same as saying 25 times 1 million, right? Or 2.5 times 10 million. Okay, is that fair to say that we have 2.5 10 millions to get 25 million? Is that a fair thing to say? What we might say is, okay, well, we can break this number down since we have a base 10 number system. We can break this number down and we could talk about it in terms of powers of 10, right? So if I take 10 times 10, what do I get? 10 times 10, right? 100, right? Times 10 is times 10 is, times 10 is, times 10 is a million, okay? So I could say, I could write 1 million as a whole bunch of 10 times 10s, right? But 10 times 10 times 10 times 10 times 10 is just saying 10 times itself 7 times, or sorry, 6 times in this case. So it's 10 to the 6. So instead of saying 25 times a million, we could say this number is equivalent of 25 times a million, or 10 to the 6. Okay? Now that's not the normal way of writing it. The normal way of writing it is such that it has one number to the left of the decimal. So the more correct way to do it is like this. So 2.5 times 10 million, 10 times 10, there's 100, 1,000, 10,000, 100,000, a million, and 10 million. 10 to the 7, okay? So 2.5 times 10 to the 7 is the same as me writing out this whole big number, okay? And it's a way to shorten it, right? There's less things to write. Not only that, but if I now want to multiply this by some other value, 4 times 10 to the 6, say, all I have to do is say, okay, well, 2.5 times 4 should be what value? Should be 10, right? So 10 on the left times 10 to whatever these two things add up to, 13, or 1 times 10 to the 14. So a really quick way of doing math with really big numbers versus if you saw this, there's a little more work involved, I think, mentally in figuring out how this shakes out, right? This is just, to me, kind of a straightforward way of dealing with it. So using exponential notation or scientific notation is beneficial in 2 ways. One, you don't have to write such a big number. And 2, when you're doing math with these, if you can do 4 times 2.5 and you can add 7 plus 6, you can quickly multiply these numbers together. Before calculators, this is how people dealt with really big numbers. They kind of like rounded them off and they ballparked them, all right? Okay, so now that we've got kind of scientific notation knocked down, let's get a little more maybe slightly difficult. Okay, so let's deal with some non-metric values just to show that we can. So let's say you know this: 1 mile equals what info do I have? 5,280 feet. That looks weird. Let me fix that. Another thing you'll notice is I've gotten out of the bad habit of using commas in here. In some countries in the world, a comma is the same thing as a decimal. So kind of the more accepted way of writing big numbers is to leave little gaps in them like this, rather than, you know, sometimes in elementary school you might write that like this. But if you end up like having to go work in, say, France, well, there a comma means a decimal, so it's very confusing, right? This is not able to really be misunderstood, right? You know what that is. So it's like a habit maybe you should think about getting into. Every once in a while, I'll throw commas in because it's old habit, but this is definitely a better way to deal with this. All right, so let's say there's anything else I can throw in here. Yeah, okay. So say you know all these things, okay? Well, now what you can do is you can start to create conversion factors just like we did up there. So if I said to you, it is 1,600 kilometers to Calgary. How many miles is this? How many inches? We'll just add one more thing here. In case you didn't know, there's 12 inches in 1 foot. Okay, now I think, and you know what else I'll throw in here, just so you have everything you need right here. You know that 1,000 meters equals 1 kilometer. You know that 100 centimeters equals 1 meter. Now, just using these, I want you to solve this. Let's think about the reasoning here. Now, you're not going to need everything you're given, but essentially, this is kind of how I would think about this. I'd start with my 1,600 kilometers, and I'd think, okay, 1,600 kilometers, I probably want to go to meters first, right? So I want to go to meters first. And then I want to take those meters and go to centimeters. And I want to take those centimeters and go to inches. And then I'll actually like answer this problem, right? I'll actually answer that one first. But then once we're in inches, we could go to feet. And once we're in feet, we could go to miles. So that's kind of the thinking here, right? So these are the factors that we're going to have to deal with. So let's just start. I'm just going to start. All right, so 1,600 kilometers. And we know that there is 1,000 meters in every kilometer. Okay. Just to make this a little bit easier math-wise, 1.6 times 10 to the 3 times 1 times 10 to the 3. I should get 1.6 times 10 to the 6 meters. Okay. So that gets us to meters. I'm going to take that. And by the way, you can do this all in one line. But I kind of like to separate it out as well, just to keep track. So 1 times 10 to the 6 meters. And I know that there's 100 centimeters, or 1 times 10 to the 2 centimeters for every meter. So now I have 1.6 times 10 to the 8 centimeters. So I get to there. Now we can go to inches. Okay, so we got 1.6 times 10 to the 8 centimeters. I have to say how many centimeters there are per inch. So let's see, what are we given here? We're given there's 2.54 centimeters in every inch. 2.54 centimeters in every inch. Okay, so now we have a problem, right? Because this isn't going to end up canceling off. We're going to end up with centimeters times centimeters, right? Because we have a per inch here. What we have to do is we have to do that inversion trick. In other words, we have to do a division, right? The answer in terms of inches should be smaller than the value in centimeters, right? The reason being is because an inch is larger than centimeters. So one thing you can't allow yourself to do is lose track of stuff like that and just plow through this, okay? So the unit should help you realize that, but it's good to kind of like be in touch with that. You actually want to do a division. So remember, you know, like x divided by y is exactly equal to saying x times 1 over y. These are the same thing, right? So that's what we're doing here. Instead of dividing, we're going to multiply by 1 over. By going 1 over here, we then invert these values, okay? So you see what I did there? I put that to the negative and changed that to a positive. Probably better to just get rid of it, okay? And now I can just do my, my math with that. Okay, so when you do this math, at this point it's probably okay to take a calculator out and do a division there, is you should get about 6.39, dropping off some of the extra decimal points. That's okay. We'll talk about how to deal with that later. And that's your value in terms of inches. 6.3 times 10 to the 7 inches. So notice as we go along, right, we're canceling off the unit we don't want. Why did it do that? We're canceling off the unit we don't want, okay? And we're leaving the unit that we do. Okay, we want to get rid of meters, keep centimeters. Okay, now we want to get rid of centimeters and keep inches. All right, so your units are keeping track along with your numbers as to where you are in the problem. Okay, so that's, you know, that's done for part B. So we just save that for later because you asked how many inches. But now we got to go to miles. So before we go to miles, we got to go to feet. Okay, so let's do that. So we've now got 6.3 times 10 to the 7 inches. And we know that there is 12 inches for every foot. 12 inches per foot. Okay. So we have a problem here, right? Our brains are telling us our value in feet has to be a lower number than our value in inches. Okay. And my values here are telling me this too. If I multiply this through, I'll get inches squared per foot. That's no good. It's not what I want. So we have to do that inversion again, okay? So we got to invert this. What we say is there's 1/12 of a foot per inch. In every inch, you have 1/12 of a foot. That way we'll cancel inches off, and we'll be left in terms of feet. So we're going to divide this value by 12. Now you end up with 5.2 times 10 to the 6 feet. Okay, and the last part is, of course, now we got to go to miles. Okay, and if we go back up here, we know there's 5,280 feet in a mile. So 5,280. I'll just leave that there so don't forget. Okay, so now we take where we are in feet. Okay, times 5,280 feet per mile. And again, right, we have that problem. We know that we're going to have to do a division. Our feet per mile is not right. We want to get rid of feet and leave miles. So we just do the inversion, change that to positive, and divide that. So you get about 994 miles at the end of it. Okay, now you won't always have to go through all these steps because you might just be given straight up that 1.6 kilometers equals 1 mile. But if you're not, you can always get there through other means, right? If you know some of these things, you can usually find your way around to your answer. All right, so this is the full method of figuring this out. And all these stops along the way are equivalent values, right? So 1,600 kilometers is equal to every single one of these things along the way. This is all equivalent to 1,600 kilometers. So that's what we've sort of found all the way through here. We wanted miles at the end, but along the way we found inches, we went through feet, and so on. Okay, let's do a time problem. So the base SI unit, remember, for time is the second. Let's just review that. We say with SI, that's the System International or the metric system. For science, we base it on M, K, and S. M being the meter, K being the kilogram, S being the second. Okay, let's say this. It takes a planet 2.2 times 10 to the 7 seconds to complete an orbit. How long is this in years, in Earth years? Okay. All right, so let's use this method and sort this out. So 2.2 times 10 to the 7 seconds. Okay, so from seconds, we should probably go to minutes. So we know that there are 60 seconds in every minute, right? But look, again, we have this problem. We got to do the inversion. We got to divide this out, okay? So we need to divide by 60. It's something like about 3.7 times 10 to the 5 minutes. Okay. 0.7 times 10 to the 5 minutes times 60 minutes every hour. Again, no good. We got to invert it. Okay. Get 6.1 times 10 to the 3 hours. Well, this is going to be a fast orbit. Holy. Okay. So 6.1 times 10 to the 3 hours. And the next one is we have 24 hours every day. So we have 1/24 of a day every hour. So that leaves us at 254 days. And almost there. 254 days times 365 days per year. Or every day is 1/365th of a year. You get about 0.7 years. So this planet's going around the sun or around the planet a little bit faster, or around the star, I should say, a little bit faster than Earth would. This might be something like Venus or something. I think Mars has a longer orbit, actually. Okay, so experiment time. Let's say you have a leaky tap, and it leaks 23 milliliters in 20 seconds. Okay, 23 milliliters every 20 seconds, right? And you want to know how much that costs per year in water costs. Okay, how much will this cost me in water costs per year? If I have a leaky tap that's leaking 23 milliliters every 20 seconds. The way I found that out was I looked at my tap. Okay, there it is, drip, drip, dripping away. I put a little cylinder under it, and I measured. Well, how much drips out of there? You know, and I'm lazy, so I don't wait a whole minute. I just said in 20 seconds, this much drips out. So what information I'll need is, well, how much water costs? Let's find it. Okay, so we just went to a website and we figured out that water costs $1.78 for every cubic meter. $1.78 per cubic meter. All right, so we're not in the right units, first of all, so we got to do some converting to start. So the first thing I'll do is I'll say, well, if 23 milliliters comes in 20 seconds, how many milliliters come every second? So what we'll do is we'll say 23 milliliters every 20 seconds gives, so that's 1.15 milliliters per second, okay? Now, let's do a little mental math, because this is in cubic meters, right? Which is a correct SI volume measurement. And this is in milliliters, which is another volume measurement. And although it's metrosized, the preferred way to deal with volumes is just in cubic length measurements, so cubic centimeters or cubic meters. So this is what we need to know. Before we can get there, we need to know some conversions in between. So we know this, because we know the metric system. We know that there's 1,000 milliliters in 1 liter, okay? But how many liters are there in a cubic meter? Okay, very good. You might know there's 1,000 liters in every cubic meter, and that's by definition. I feel like the liter should have an L on it, or we can't tell what it is. Okay, so 1,000 liters is 1 cubic meter, and 1,000 milliliters is 1 liter. Okay, and this is just by definition. All right, so when they were originally doing the metric system, they took a cubic meter, right, filled it up with water. 1/1000th of that was 1 kilogram. That was all. That volume was also designated as being 1 liter. So we should have all we need now. Okay, so let's see if we can get there. So first of all, we have to figure out, I think, maybe the best way is to go to how many milliliters we have every year. Okay, let's do that first. So we have 1.15 milliliters coming out of there every second. Okay, now we're just going to deal with this. We have 60 seconds every minute. Okay, and we have 60 minutes every hour. So what this should do, if we do this multiplication, it should give us how many milliliters we have per hour. Seconds cross, minutes cross, and we should get ourselves there. So let's give that a try. So you should get 4,140 milliliters per hour. Okay, and then we know that there's 24 hours every day and 365 days per year. We'll ignore leap years for now. So you get a big number. You get something like 3 times 10 to the 7 milliliters per year. Okay, hours go, days go. We're left in per years, and we still have milliliters. That's milliliters per year. So we found milliliters per year. Now we've got to take milliliters over to cubic meters. Okay, so we're going to do this. We know that there's 1,000 milliliters for every 1,000 milliliters for every liter. Okay, but that's not going to cross off milliliters. We have to do a division, right? The number we should get is smaller. There's less liters than there are milliliters. So we're in the metric system, so it makes it easier. Essentially what we're saying is 3, why does it keep doing that? 3 times 10 to the 7 milliliters per year times 1 times 10 to the negative 3 if you want, okay? Because we're, this is like 10 times 10 times 10 on the bottom, or 1 times 10 to the negative 3, okay? So it's the same thing there, and that's liters for every given milliliter, right? Or milliliters for every given liter. There's 1/1000th of a liter in a milliliter. So 7 plus negative 3, we can just say we're at 3 times 10 to the 4 liters per year. Okay, and we have to do one more thing, right? We have to go from liters to cubic meters. Okay, and we know that there's 1,000 liters in every cubic meter. We do the same thing, right? Okay, like that. So 3 times 10 to the 1 then, meters cubed per year. We're almost there. Okay, so 3 or 30 if you want, meters cubed every year times $1.78 per cubic meter. It's going to cost you about 53 bucks. 53 units are dollars. These are gone per year. Okay, so the last thing I just want to deal with here is just converting when you're dealing with squared units. This often causes people issues. So for instance, let's say that I have 1 square meter here, okay? I have 1 square meter. How many square centimeters is that? Is it 100 centimeters squared? It is not. And it's often a mistake that people do a direct conversion here. It's not how it works. You have to realize that each side of this thing is 100 centimeters, right? If it's 1 meter on a side, then each side is also 100 centimeters. So you're actually talking about 100 times 100 or 10,000 centimeters squared. So when you're doing conversions with squared units, you got to watch yourself, right? Or if we want to go even the next step, each side is 1,000 millimeters, right? So it's actually 1 times 10 to the 6 square millimeters in there. Does that make sense? And one way to kind of help your brain understand why that is, instead of just taking my word for it, is to think about what you're actually making here and think of it like a grid. So if we're talking about centimeters, you've got like 100 along each line, right? And then you're stacking them up, 100 here. So you got 1 box, 2 box, 3 box, 4 box. So right along here, right along the bottom row, in the first centimeter tall, right there, you already have 100 square centimeters just along the bottom, don't you? And then by the time you get 2 centimeters up, you're already up to 200, right? You got to go all the way up to 100. Each one adds another 100 centimeters squared onto there. Does that make sense? And then the next step, of course, is going to be to cube this, okay? So I get rid of this here. When we want to cube this, it gets even more interesting. That's not what I want. This whole thing. It's not going to give me that whole thing. Well, whatever. I'll just draw this on here. If we cube this, we take a cubic meter. We've got 1 meter, 1 meter, and 1 meter. We've got 100 centimeters by 100 centimeters by 100 centimeters. So you actually have, what you end up with here is you get with 100 times 100, so 10,000 times 100, you actually end up with 1,000,000. 1 times 10 to the 6 centimeters cubed, or 100 cubed. Do 1,000,000.